So if you go to Pact/examples, there's a few examples in here. And if we go to accounts and we look in the accounts REPL file, here on line 17 is the syntax for type check.
And when I run this file, it told me that something did not type check.
I did try coded symbol, but that didn't work. So,
okay, did you get Pact 2.3 or Pact 2.4? 2.3.8? Interesting. I'm not sure off the top of my head. Let me
just, my module is called critters, then passing type check code critters. That doesn't work. Not get it.
So I think.
It says no such module critters. Oh wait, hold on. Let me try this one more time.
Yeah, I think that's going to be the module name.
Yeah, I'm passing module name as a quoted symbol.
As a quoted symbol?
Yeah.
Did you do...
No, I did not do begin and commit transaction.
That may be important. I'm not sure.
Yes, it's very important.
Okay. Good to know. Also, something to point out, it would probably be useful to refer to these examples in the repo. So you're going to define your module, and then you are going to have a few things after the module. You're going to have, at the very least, create table lines to set up whatever tables you need to have set up, and potentially other stuff to like do operations to get the state into the state that it needs to be to start, to make the contract run. You can have nested schemas. So you can have a schema that then refers to another schema. And I believe that is where you would... So schemas, my understanding of them is that they are a thing that is useful with your JSON structures, not something that is necessarily specifically for tables. And tables are key value with a string key and a JSON value, typically. I think it has to be that, if I remember correctly.
For generation, owner, matron ID, sire ID, genes.
Yep.
Now I'm a little bit further. Could you repeat that?
Yes, absolutely. So generation is going to be an integer.
Okay.
Owner is going to be a key set. And IDs, whatever you chose for your IDs. I chose integers, which I can't necessarily... I don't want to impose on you.
So UUID maybe, or?
Well, I don't know if we don't have built-in support for that.
Okay.
It's going to be either an integer or a string.
I see.
And if it's an integer, then you're probably going to have some auto-incrementing facilities that, like I mentioned. And if it's a string, then you're probably going to have a little bit different interface than if you had implemented it with an integer, because how are you going to generate those strings? You're probably going to have to ask the people to use their own strings, and that's not necessarily a bad design decision. It's just going to change a little bit of the nature of things, slightly. You could even abstract over that. Like the actual CryptoCritters implementation, most of it is interfaced with a web API through their site. And so you could implement the IDs as strings in your Pact code and then have something else that makes them be integers de facto. Choose whatever you want there. Whatever you choose, that's what matron ID and sire ID will be. And then genes, I would suggest using a string. I initially started using an integer, but Pact does not have bitwise operations, which we don't want to put. We won't categorically rule it out, but in general, we are going to design for explicitness, and bitwise operations are a little bit difficult to understand and opaque sometimes. So that's why I think you should use string for genes. These two. And I think it's this one that sets up this, makes this data structure available. I'll mention this. This brings up a really good point, her question. Another thing to be aware of is that Pact's execution model also assumes that there's like some data being made available at execution time. I'm a little hazy on this actually. And that's what the env data function does, is it sets up whatever JSON you want to have set up, which in some of our examples on the web REPL, which so we're calling this env there we go. We're calling this env data function and basically making this JSON data structure available at the or to your Pact code at runtime. And when you run it actually in a blockchain, this will be something that is also there, is this data structure. And then we read that down in the define, where's the define key set line? Oh, maybe I should go back to hello world. Right here, we say read key set, admin key set. This is coming from whatever data has been defined as like the environment data that is available to the module when it is run. Eventually, we will probably have first-class support for this in our web REPL. So instead of having these lines at the beginning of your code that set this stuff up, we'll probably have different boxes that allow you to define those things and make it a lot more obvious what's going on.
Define key set to create any variables. It says that it's not found in type check.
I believe it does, but I'm not sure.
I just use read key set, admin key set to set the owner, and that works.
And that works?
Yeah, read.
Oh, you directly use that. I see.
Instead of define key set? I bet define key set makes that available as a symbol.
Yeah, but it failed type check, so I
Sure.
skipped it.
Where is the primary key of the ID defined in your schema? I don't see how you do that.
I didn't put that here.
It's just ID. It's just the ID. There's no. You don't have to define a column for a primary key.
There's always a primary key that is always an integer.
It's a.
No, it's always a string.
It's always a string.
Yep.
Because it's key value.
Yep. So, yeah.
Like this is the standard key value model.
Yeah. Centaur.
Yeah.
Okay. Yes. Okay.
And it's more powerful than if you fix people to integer ID or integer keys.
Exactly. Because of the bleeding zeros.
So that's why we went the way we did.
Yeah.
I understand your feeling, and
It could be worse.
we can add more things later to provide convenience for commonly used functionality, and my view on this is that we want to start out with a language that's simple, simple to understand, simple to implement. Just simplicity trumps everything. And then as we see more use cases and justifications for more complex features, we'll consider adding those.
Do you tend to reset your database in your REPL during development, or do you tend to let it build up?
So if I have been using Atom because I needed to get familiar with it, and if you're using Atom, then it's redoing your REPL every time. It's rerunning from scratch.
Okay.
And so when I have done it your way by actually running in the REPL, I've just been pasting in the stuff from my REPL file, or I guess as we discovered earlier, you can just load the REPL file. So yeah, my use cases has been to just reset all the time.
I can observe that my create function is working because every time I reload, the table grows by 1 row.
Ah, nice.
How do I test my thing?
What is run in Atom?
Oh, it wouldn't?
I'm asking, what is run in Atom?
What is run? Go to... No, it just, saving the file does it automatically. But if you go to packages, Pact language, toggle trace, and then create a critter.repl file.
Oh, so a new file? That's
Yeah. Do say
critter.repl?
yeah.
Aha.
And now you can
You say here it.
let me get you go open a browser tab for our web REPL in your browser.
In my browser.
Yeah, in your browser, go to kadena.io. Oh, it might be this tab.
Yeah, I have the bajillion.
So now copy these 2 lines and put these as your first 2 lines in your REPL file. And you can even delete the comments later. And then you go back to the REPL. This is where it deviates. Go to Pact repo. Yes. Now scroll up all the way. Let's see, click here. Go to accounts.repl. So cargo culting this stuff is pretty effective.
I get it.
So copy 14 through 16. And maybe even 17 too if you want. That's up to you. And paste that into your REPL file.
But it'll have to change this.
Yes.
Critter. And that would be.
Probably critter or critters or whatever you called
I
it.
think I've only used the singular anywhere, I think.
So now
No, module is critter, so that
Critters.
needs to be the module.
Yes. Now, what I do is make this a little wider and then put the REPL file side by side. This is just,
Sure. No.
Choose to ignore this later. Yeah. So now yes. Now we can start over here. You can just start playing. You can run your create critter function.
Just.
Yeah.
I'm sure it won't work yet, but nonetheless. It takes a string, so just who.
Yeah. Now. And did you get Pact installed with Brew?
Yeah.
Okay.
No, I took the binary.
Took the binary. Okay. And is it available in the path?
It should be, yes.
Okay. So now you've got an error here, which is probably why it's not.
Yeah, it doesn't how I've handled the IDs. I'm using the integer with a 1-up, and I've boggled something somewhere.
Okay, so ID key.
I need
Where
two
is
IDs. So
Where is ID key coming from? The parenthesis needs to be before ID
God,
key.
I'm Pythoning instead
Yep.
of...
No worries, I totally get it. And then ID 2
So I probably...
is not in scope.
Yeah, So I read it, I update it, but I need a second one for the sire. So I've probably done this wrong.
So this with read. This maybe needs to be ID 2.
I need to read the second, and then update,
and then call that ID 2 maybe. Or maybe this is ID and ID 2.
I only have one table, so I'm in the database. There's just one ID that's getting upped, and then I do it twice. So.
Let's see here. Okay. Yeah, for lunch, I'd say whatever you want. I don't have to necessarily go anywhere at the moment, so I'll stick around. But what's the official time on the end of lunch? An hour? So yeah, if you don't want to stick around, if you do care about eating, be back here at 1. And okay, excellent. Okay, so refreshing back to the outline, we've got critter creation done. Everyone's got that, correct? It just started working again. Very strange. So we have critter creation working. Next up, ownership transfers. And the ownership transfer function is going to be fairly simple. This function signature, transfer a critter, and you're going to give it the new owner, which is a key set, and the critter ID. And have at it. Oh, that's a good question. I think I probably didn't bother to care. Let me see what I actually did.
There's no unit type. Oh, I guess you could have an empty object. String usually.
Yeah, it just returns string by default. And that's because the update function returns string. So in my implementation, the last function called in this transfer critter function is the update function. And that returns a string. So it just returns update or write succeeded. I don't think that is super... In my thinking about the problem thus far, that hasn't been super important. So yeah, take a stab at that and let me know what questions you have. How's the ownership transfers coming? Ready to move on, or should we give it a little bit more time? Well, we've got plenty of time. I don't think I wouldn't be surprised if we get out early. We can spend some more time. Is there a particular...
Fact checking was fine when I go to test it.
Yeah. Sometimes there are... I think the error locality is not necessary, but this is happens everywhere. Haskell has the same problem too. The error message will say, "Oh, this thing is wrong," and the actual problem is somewhere else. I've noticed a few situations where that happens with Pact as well.
I don't think.
How about this? I'll go over the next section, and then since it's the same kind of thing, it's another evolution of this transfer function. We can like work in some of the checking of your existing transfer function then. Okay, cool. So permissioned ownership transfers, it's really one line. You just add an enforce keys or enforce key set function, and you're enforcing the owner's key set. So permissioned is pretty simple, but there's an interesting issue here, and I first started thinking about this issue when I was reading the actual CryptoKitties code. They have a comment in their code that says, like, danger. You must get this transfer function right. And now think about it. If you're saying transfer a cat ID or critter ID and a public key, and you mistype the public key, the critter is gone forever, because there is nobody that has the private key that corresponds to that public key, and there's really no way for the blockchain to know that, there's no way for it to check the public key, because there's no registry of them or anything like that. It's just a number or set of bits. So it'd be nice, I thought, to make our transfer function safer, so that we cannot accidentally transfer our critters into oblivion. And that's the next task for you. The way that we want to solve it is with a multi-step transaction. So first of all, instead of actually transferring the critter, and where transfer, like completing the transfer means setting the owner field to the new key, what we want to do is we want to make some note that we are transferring. That's the first step. So the owner of the critter says transfer critter key, and then in order to complete the transfer, the critter stays owned by the original owner until the new owner calls complete transfer. And then complete transfer only can be, we have a permission on the complete transfer function that makes sure that it can only be run by the key that the person wants to transfer it to. And that two-step nature solves this problem. And then we also add a third function that allows the original owner to cancel if the transfer hasn't been confirmed yet. Does that make sense, the way I described this process? And this allows us to we're guaranteed that our cats never go into oblivion, because the confirmation of the transfer has to be done by someone who has that private key.
Yeah. So the idea is to relate this to enforce key set. The transfer is initiated by the current owner.
Yes.
And then
it's completed.
And then we enforce that the completer is the new owner.
Correct.
Okay.
The complete message has to be done by the new owner, and then we guarantee that the new owner exists. Now, we don't guarantee that the new owner doesn't lose the private key later, but that's their problem, and we can't possibly protect against that ever. Make sense? So this expands. I would say keep your existing transfer function. That's still useful to have around, at least until, if you're actually building this application, I'd probably keep it around for for a while until you get a lot more tested and ready to deploy. But so this will be 3 new functions. One for initiating a transfer, one for completing a transfer, and one for canceling a transfer that's already been initiated but has not been completed. This is going to require you to keep some new data around somewhere. And the way that I would recommend doing it, or the way that I did it, was to add 2 new fields to your critter definition. One field is just a Boolean flag that says we are transferring. And the second field is a key set of who we're transferring to. There's a number of different ways you can implement this. You could implement this as a separate transfers table where you keep the transfer information. But I think for the purposes of this, the simplest and most least amount of new code needed is going to be to just add 2 new fields to your critter schema to track this information. So if this helps at all, here's some stubs for the safe ownership transfer functions. Not a whole lot of information here, but gives a little bit of the shape.
I'm not sure how to do cancel because there's no. I didn't see a built-in function for delete.
Aha! How did you store the transfer information?
I have another table which has only a recipient.
Right, and this is why I suggested not to do it that way.
Wow.
And instead add.
When I first described it, I really wanted to do it.
And now you have discovered the reason that I didn't suggest that way.
That there was no delete, but I said, you know what? We can probably figure this out later.
Yeah, I actually... Joel, do you have any...
What was the question?
Why isn't there a delete from the table?
I don't know. I think that there could be.
Yeah, I think there could be 2. I'm not sure if there has been a conversation about implementing that. But I will make a note to bring that up because I think it's a valid point.
It doesn't matter semantically a lot in this case.
Right.
Because the only transfer you can repeat again is the one that transferred it to yourself, so, whatever.
Yeah, but there could be situations where you want that. Yeah. So I would suggest just storing it in the kitty table or the critter table, and then you don't need to delete things. You just need to set a bool back to false.
Well, I think that the state of no pending transfer is proposed recipient is yourself.
Oh, that's reasonable. But okay, then you can detect that by just checking whether owner is equal to transfer recipient.
Yep.
Yeah, that's a decent convention. Lets you skip the extra field. Okay, so we've got safe ownership transfers done. We've got basically two things: the simple breeding, and what I call asynchronous permissioned breeding. We can do some looking at clock auctions if you want. The reason I put that as a stretch goal and didn't plan on it is because that starts to require more of the blockchain infrastructure, like block height and things like that if you really want to deal with some kind of measure of time like we were talking about earlier. And I hadn't gotten to that in my own writing of this code, so I don't know exactly how much we have fleshed out there and how much we would be able to concretely do. So we are supposed to have a break from 3 to 3:30 for just like meeting people. We could start forging ahead now, or we could kind of break early and then come back at 3:30. What do you think?
I don't know. I'm okay
Cool,
to keep going.
Yeah, let's go.
Okay. Simple breeding then. This is not too hard, but it gets into some interesting, more like nitty-gritty details of representations. Yeah, just a simple function that allows you to breed two critters. This will be potentially be a helper function for the next phase. I have it listed as integers here. As I told you before, I think you should use strings. The way that I set this up is to do the first X. You normally do a crossover. If you have If you have one parent here, you like pick the typical way to do the genetic operation is to pick a random spot in the string. And so if your spot is here in the middle, then you take one side and the other side, and so the child would be either all zeros or all ones. That's the typical thing, and then it's nice you get more variation if you choose a random spot. So you could, but we can't choose random numbers, and this is a thing that we may need to add some more infrastructure for. The way that I would most obviously solve this problem would be to calculate some hash, which Pact does have functions for, and then use the data from that hash to figure out where you want to split your crossover at. Some of this stuff may be tricky at the moment, and may or may not even be very doable. But I would propose for a first cut, maybe just say you're going to split at 5 characters in, just some fixed number of characters in, or split at halfway, or whatever convention works for you. If we were really going for a realistic genetic algorithm in breeding, we would also want to do a mutation. And we would want to mutate a small percentage of the time. And we would want to mutate a random bit in the bit string. But I'll leave that up to you as to how sophisticated to get on that. Is there anything unclear about this whole notion?
Aside from like creating a table and putting a seed in it, and then like copy pasting a Merced Twister or something.
Yeah.
What kind of information do we have, like block height and so forth, that we might use as like non-deterministic until you get in a block sort of thing, sort of information?
So we have a couple of functions. Let me find them. There's one function called tx hash, which gives you the hash of the current transaction as a string. That seems like a potential source of randomness, of pseudo-randomness to me. We also have just a hash function that can hash anything, and so you could hash the two parents' genes. You could hash some, like one of the parents' genes. There's all kinds of things that you could hash to get a source of pseudo-randomness there. The hash that we use is a Blake 2B 512-bit hash. The problem with using that is that its output is a string. And that's not, and it's looks like it's a base 64 encoded string. And so that's not the most easy thing to convert into an integer, which is what you probably want to do. So there are some limitations there. It would certainly be helpful to just play around with whatever ideas you have and skim the docs and kind of like see what different approaches we can come up with and what things may or may not be, tools may or may not be needed or are needed that may or may not be there right now. At the end of the day, what you really want is a function that takes two genes and gives you another gene, some way, somehow.